Hi guys, today I would like to talk about statistics, importantly descriptive statistics. So there are two types of statistics, descriptive statistics and inferential statistics. And descriptive statistics plays an important role in understanding the data. So even if you are a data scientist or data analyst or business analyst, it is very important to understand the past data. So for that you can apply some statistical method, then it will help you to understand the past data. So descriptive statistics is the method which describes the data and it gives the summary of your data. So main focus of descriptive statistics giving the summary by applying the statistical measures on your data set. Let us assume so you are the class representative and then you would like to determine the t-shirt size. So in that case you need to find out minimum t-shirt size, maximum and average. So this is the population. So population means this is also a statistical term which represents the group of data. So let's say there are 60 members in the classroom. So from this population you would like to know what is the average size of the t-shirt, what is the maximum, what is the minimum. So these are the statistical terms or statistical method which can be applied on your data so that you'll be knowing these. And we can categorize descriptive statistics into two types, measures of central tendency and measures of variability. So let's discuss in detail of this central tendency. As the name says, central tendency means knowing the middle position or central value. So three measures falls under this category: mean, median and mode. So mean means it's a simple arithmetic average. So when you have a data set or data values, then you need to sum up all the values and then dividing those values with the total number of values. So this is an equation. X bar means mean, which is equals to sigma of this all the values, summation of all. Xi means I values ranging from 1 to n. So all the values are summed up and then dividing them with n. So let us take an example how to get the mean value programmatically. And here the very important point to be noted is most of the people are having a wrong assumption that statistics means doing some calculations. So that is actually wrong perception. So you don't need to do any calculation on the paper, right? So we have just predefined methods and we use them. So here I'm taking a sample data, generating a sample data. So importing pandas. As you know, pandas are used to create a data frame, and here I'm using numpy. So importing numpy as np, and my data frame is created. This df1 is user defined name. So df1 is equals to pd.dataframe, and in this data frame I would like to have two columns. One is employee ID, another one is age. Then how the values of employee IDs are coming. So creating a dictionary here, dictionary of employee ID is equals to range of 6. Range of 6 means it will give us the values from 0 to 5 only, always one less. Similarly, age is equals to generating random integers here by using the predefined method randint, np.random.randint. So this randint method gives us the random integers. How many? Totally 6 here. So we mentioned the size as 6 and the values are coming in the range of 18 to 30. 18 to 30 means not exactly 30, up to 29 only. Then I'm printing my data frame. So these are the values. Employee ID values are 0 to 5 and then age, random numbers are generated. So totally 6. So on this data frame I would like to know what is the mean, means average age and average employee ID. Then how do you do that? So first of all you need to access a column. So df1.age.mean, then it will give us the average age. Average age is 23.5. You can also do the same by accessing the column like this, df1.age.min. So this also gives the same value, 23.5. And we can also apply mean operation on complete data frame. So when we say complete data frame, we have two columns here, employee ID and employee age. Then df1 dot mean, so it will give us the average value. Average ID is 2.5, average age is 23.5, and these values are float 64-bit type. Then let us see how to calculate median. So median means middle value. It always gives the midpoint of the frequency distribution. It will give us the middle value in the given list. So this can be calculated like this. If the count is odd, that means when you have odd number of values, then the median is the value which is at n plus 1 by 2. Else, if your count is even, then you need to take the average of middle 2 points, n by 2 and n plus 1 by 2. And here also we have a predefined method, just apply it on age. So df1 dot age dot median, so giving the middle value as 22.5. And mode means the frequency of the value. So df1 dot age dot mode, so you can see we don't have repetitions here. All the values are unique in the data frame. All these values are unique, but sometimes if the value is occurring multiple times, let us assume that 23 is totally 3 times in the age column, then we'll be having the 23 as mode. Okay, the highest occurring value is written by the median, sorry, by the mode. So as we have the single occurrence of all the values, so all these values are considered as the mode. The same can be done by accessing the age column in this way, df1 dot age dot mode. So this also gives the same result. So we have pandas function that is describe. So this single function is enough to get the descriptive statistics. To summarize your data, so this single function is enough. So this function will give us the values for count. Count means total number of rows. We have 6 rows. And mean means average ID 2.50, average is 23.50. Then STD means standard deviation. So I'll be talking about that. What is standard deviation? Then min means minimum value, and then it also gives the maximum value. So as per this data, we can say the minimum age is 23 and maximum age is 29.0, and this is 25 percentile data value, then 50 percentile data value, and 75 percentile data value. So this is about measures of central tendency, in which we have 3 measures: mean, median and mode. But remember, mode is mostly applied on object type of data, means string type of data. And measures of spread. So measures of spread means how the data is spreaded. So under this we have these measures: range, standard deviation, variance and interquartile range. So let's get into details. So range means the difference between the maximum value and minimum value. So here we don't have the predefined method, so that's why we need to calculate manually. So range is equals to max of x is your data, minus min of x. So I'm displaying the data frame again. So under this, you see what is the minimum value. So we already got to know 20, and maximum value is 29. So we need to calculate manually. So this r is a user defined variable. R is equals to df1 dot age dot max. So this will give us the maximum age value, and this will give us the minimum age value, and then displaying the value. So 29 minus 20, which is equals to 9. So range is 9 here. Then let's define variance. So variance means it's the average distance from the data values from the mean. Okay, average distance from the mean. So you need to calculate the mean, and let's say there is some attribute x. So how that x is having the distance, average distance from the mean. So we can calculate like this: variance, which is denoted by s square, which is equals to sum of x minus x bar whole square divided by n. So what is x here? X is the individual data point from the data set, and x bar means average, mean, and n means the total number of samples, total number of rows. So here also we don't need to do any calculations. We have the direct method, that is VAR, stands for variance. So the variance is 11.5. Then another measure in the measures of spread, IQR. It is also known as IQR, stands for interquartile range. So this can be calculated as Q3 minus Q1. Q3 means quantile 3, quarter 3 minus quarter 1. So we need to calculate manually. So df1 dot a is dot quantile. So quantile 75%. 75% means quarter 3, and q1 means 25 percentile. So this will return us two values, 25 percentile and 75 percentile, and I'm storing those values into variables q75 and q25, and then having the difference between these two, so that gives the IQR. So interquartile range value is 4.0. Then what is standard deviation? Standard deviation is nothing but square root of variance. So after getting the variance, you need to do the square root. So this is an equation. Sigma is equals to square root of sum of the difference, that is xi minus, this is the variance, okay, xi minus, this is mean actually, so square divided by the sum of all values, then for all this square root, simply to say square root of variance. So you are calculating, you can do the manual calculation, but here we don't have to do manually, so we have a direct method. STD stands for standard deviation. So standard deviation on A is 3.39. So 3.39. Then there is also measures of shape. So this is also important to understand your data or to study your data. So in this we have two metrics, two measures, skewness and kurtosis. So importantly, these measures of shape gives the shape of your data, how your data is distributed. Okay, how your data is distributed. So we have two metrics, skewness and kurtosis. Let's first understand skewness. Skewness means is the measures of asymmetric distribution. Symmetric and asymmetric, so you need to understand these two terms. Symmetric means data is normally distributed. Asymmetric means not normally distributed. So remember, skewness is asymmetric distribution. So here in this also we have two types, positive skewness and negative skewness. So positive means the skewed distribution has a tail which is pulled towards the positive direction. So this is positive skewness. You are having a slope towards the right side, so this is a positive skew. And sometimes there is a skewness towards the right side, and also called as negative skew, means you are having a slope towards the left side, known as negative skew. So understand the difference. Positive skew means skewed distribution which has a tail pulled in the positive direction like this, and if the tail is pulled towards the negative direction, then that is called as negative skew. So positive skew, negative skew. In other terms, we say this as it's the slope is towards the left side, we say left skew. As the slope is towards the right side, we say right skew. So in the data, when you plot your data, if there is a skewness 0 means normally distributed. You see this dotted line, so this is normally, let us assume this is normally from here to here. Let me plot it so that you guys can understand. So let's say this is normal. I'm just plotting on the graph. So this is normal, but this slope is towards the left side, so this is left skew or negative skew. Here this is normal, actually this is normal, but there is a slope towards the right side. This is the slope towards the right side. So this is a right skew or positive skew. So here also we don't need to do any calculations. So we have a direct method. So after applying that and based on the value, let us assume if you have got the skewness value as 0, it means data is normally distributed. And if the skewness value is greater than 0, means positive skew. And if the skewness value is less than 0, that is negative skew. So I'll show you that. Then another metric is kurtosis. Kurtosis means peakedness. Okay, peakedness. It means that you are having a steeper, so means positive skew to kurtosis, and if the curve is flatter, then that is negative kurtosis. So you can also represent that by using this using this figure. So this is normal distribution. Just give me a second. So this is normal distribution. This one is normal distribution. And positive kurtosis. Positive kurtosis means this one. So this is positive kurtosis. And negative kurtosis. Negative kurtosis means, let's say this one. This is negative kurtosis. So this is how the curve, how the data is distributed. So based on this, you can determine normal means green color, and positive means this orange color, and negative means this blue color. So what is happening here? So normal means distributions are moderate. Okay, most of the data is distributed in the middle. So moderate in breadth, and curves with the medium peaked height. So medium peaked height, this is the medium peakness. And positive means crash the normal. It has the curve crash the normal limit. And this one is negative, means less. It is having the fewer values in the tails. In the tail you are having fewer values, and fewer values close to the mean. That means the curve is having a flat peakness. This is a flat peakness. What about this? This is very high peakedness, that is positive kurtosis. So in other terms, we can say based on the range of values. So for example, the normal distribution means which has a kurtosis value 3. This is the kurtosis value 3. And if it exceeds, that means if the normal distribution has the kurtosis exactly 3, that is a normal. So this is normal. So normal means also known as mesokurtosis. Basically we can categorize into 3 types: mesokurtosis, leptokurtosis, and platykurtosis. In other terms, we say normal, positive, and negative. So normal distribution means has the kurtosis value 3, and if it is greater than 3, then that is called as mesokurtosis. Mesokurtosis means is normal. Normal means 3. Okay, normal means 3 only. Exactly 3 means mesokurtosis, normal distribution. And if it is less than 3, means this one, platykurtosis, this flatted curve. And the other one is leptokurtosis, means greater than 3. So greater than 3 means this one. It means positive kurtosis. So based on the range of values, there are 3 types: mesokurtosis means normal, and this is negative, and this is positive. So we no need to worry about all these things in the all these things, because if you are the beginner, so it might be confused to you. So you just leave it, because at the initial stage, if you just get into more details, then you'll get afraidness. So that's why, so you can just leave it, because if you simply apply the skew function, based on that you can determine if there is a kurtosis, or if there is a skewness. So based on that you can decide whether the data is normally distributed or abnormal. So let us see how to know the skewness. So I am applying the predefined method skew on A's. Then this gives us the value. So what is this value? So here we can say there is a positive skewness. Understand, the values of age are positively skewed. Sometimes it can also be negative, so negative skewness. So after applying skew function, if the value is 0, means it is normal distribution. Got it? So here this is positive skew. And we can also have a distribution of the data by using dist plot, which is provided by the library cborn. So importing cborn as SNS, then SNS dot distribution plot of age, then KDE means kernel density estimation, which is equals to true, means you are having a arc. So you can see the slope is towards the right side, so we can say right skew or positive skew. So we can also graphically know skewness, either positive, negative or neutral. So you can see it's a positive skew. And even we no need to worry about calculating the kurtosis. We have a direct method, kurt. So as per this, it is negative kurtosis. Negative kurtosis means this kurtosis. So it's a flat curve, so almost flat curve. So that's why negative kurtosis, this one. So this is about descriptive statistics. So remember, the main use of descriptive statistics is to describe your data so that you'll understand what is your data. And in descriptive statistics there are two types, importantly, measures of central tendency and measures of variability. And as we have discussed today, in measures of central tendency you have the measures mean, median, mode. Similarly, in measures of spread or measures of variability, you have the measures like range, standard deviation, variance, and interquartile range. And when we are doing some data analysis, no need to do this individually. So because the pandas is providing us very important function, that is describe. So if you just describe your data, this one, if you just apply describe method on your data frame, then you'll be coming to know the mean value, standard deviation, minimum, maximum. So this single function is enough to know the descriptive statistics. So that's it from me today. So if you have any queries, you can also comment and you can also raise to us, and do subscribe our channel to get more updates in the near future.